Hello everyone, welcome to this video wherein I am going to discuss simple interest and compound interest. Now SICI is a very important topic and there are a lot of question types that exist. So what I will try to do in this particular video is I will tell you what all concepts are there that are important from the point of view of the CAT, and also we will solve one question from each of the types that I have mentioned. So you will have a good overview of SI and CI over the next few minutes. Now to start with, what exactly are we going to cover? So first of all, I am going to share a very nice cheat sheet with you. You can take a screenshot or download this particular image from the link in the description box below. So you can check that out. You can add it to your collection. As we progress, I am going to share more such cheat sheets. The second thing we are going to do is we are going to look at a question that involves rule of 72. What is it? How many years does it take to double a sum of money if the interest rate has been given? Or if I know that something is going to double in so many years, then what exactly should be the interest at which I should invest this particular sum of money? The third thing is difference between SI and CI for 2 years as well as for 3 years. We are going to be looking at questions from this particular concept. Alligation rule in SI/CI, can we apply it? Yes, we can. So I will share a question which will talk about this as well. And in terms of installments, we should know how exactly do installments work. What exactly do we do when the installment value changes every year? What happens if the installment remains the same as is the case with EMI? We are going to look at those questions as well. Now, this is basically the cheat sheet that I was talking about. So simple interest and compound interest cheat sheet. We have all the important formulas, all the important topics that we need in this particular context. So you can have a look at simple interest. First of all, the formula is P into R into T by 100, where P is the principal, R is the rate of interest per annum, but it can also mean a rate of interest in terms of rate per period or per term, whereas T is the time in years. Generally yes, but sometimes it can also be in terms of months, but we have to match the rate of interest per term, and the number of terms should match. So if it is quarterly, then the number of terms will be 4 per year and the rate of interest will be divided by 4 for each term. That is what happens. Now the amount at the end of the period is going to be the principal that you had invested plus the simple interest that was accumulated. Now in terms of shortcuts, SI is directly proportional to principal as well as rate of interest as well as the amount of time for which you have invested. The more money you invest, the more return you are going to get. The higher the rate of interest, the more return you are going to get, and the larger the amount of time for which you stay invested, the more the money you are going to get. Also, if you look at it in terms of ratios and percentages, you can think about it. 10% of a number is nothing but number divided by 10. 20% is the number divided by 20. 30% is the number divided by 30, and so on and so forth. 5% is basically divided by 20. 2% is the number divided by 50, and so on and so forth. 30% ke liye you'll have to do something slightly different. But that is basically how it works. So you can calculate SI quickly in your head by using these formulas. Also, in terms of compound interest, there are a lot of people who find it difficult to understand this, but amount at the end of a certain amount of period is going to be the final resultant that you're going to get. There is no interest per se when it comes to compound interest. The additional amount that you're going to get, the additional bit that gets added to your principal is going to be the interest. So just remember this formula: P into 1 plus R by 100 the whole raised to T or the whole raised to N, whichever way you would have studied it, where again R is the rate of interest per term and T is the number of terms. Again, if you want to figure out what exactly has been the compound interest that has been generated, it is going to be the amount that you are going to get minus the principal that you would have invested. Now, there are a few things that are there. For 1 year, there is a shortcut, very straightforward. You know how much is the compound interest. It is going to be the same as the simple interest. For 2 years, if you look at the difference between SI and CI, you are going to see this interesting thing. If you expand this, you are going to see 2 PR by 100, which is the simple interest, and P into R by 100 the whole square, that is going to be the extra amount. So for 2 years, you can simply say that the difference between compound interest and simple interest is going to be P into R by 100 the whole square, or sometimes people say PR square. Now in terms of 3 years, this is basically where things become slightly trickier. Again, you can see that the first term is fine. It is 3 PR by 100, which is going to be the simple interest that would be generated after 3 years. But these are the extra terms that you have. And what are these terms? You are going to see 3P into R by 100 the whole square plus P into R cube by 100 cube. In simple terms, what we can write here is that we can say that the difference between SI and CI is going to be 3P R square, R by 100 the whole square. We can write this as R square itself, plus you are going to say P into R by 100 the whole cube, or you can say P into R cube, something like this, right? So P into R cube is what we can write this as. I'll just make it clearer. And that is basically something that you can remember, right? So this is basically the difference between SI and CI over 3 years. This is the difference in between SI and CI over 2 years. We are going to look at some questions which will use this particular concept. Now, in terms of one thing, you have to look at this rule of 72, as I was saying earlier. If, let's say, for example, you know that the money is invested at the rate of 12% per annum, then how many years approximately is it going to take it to get doubled? Now the answer is going to be 72 divided by 12, that is 6 years. If you invest it at 9% per annum, then what is going to happen? You are going to double the money in 8 years. If, let's say, for example, you invest it at a rate of interest of 4% per annum, it is going to take 72 by 4, that is 18 years. If you invest it at 36% per annum, you will double it within 2 years. So that is basically what it means in terms of the rule of 72 that exists. It's an approximate calculation, right? It's a shortcut that you can use for some question types, but it is broadly an approximation. You will be able to calculate things quickly in your head if you know this particular bit. In terms of conversions, we have mentioned the fractional equivalent of 3 months, 6 months, 1 month, and so on and so forth. If R% per annum, then R by 12% per month. If R% per annum, it means that R out of 100 per 100 rupees, or R rupees per 100 rupees of investment. Now, in terms of the key tips that we have these things that are there. You have to read it very carefully, whether it is SI or CI. It's very important. If you do not know which one is it that you're calculating for, then you might end up in some amount of trouble. If you overthink and do not read it properly, or you get distracted, you might end up calculating the wrong interest. Also, you have to look at the time period very, very diligently. You have to understand whether it is half yearly, quarterly, or annually. Also, you have to look at CI as the, you have to look at a formula or the shortcut that is there. So you can either remember these things, or you can work backwards and try to figure out the answer on your own by doing a bit of calculation. Installments is very important. You have to understand how many periods are there, and the formula for installments is right there at the bottom of this particular image, so you can look at it. And most important thing, we are going to look at this particular thing as well in today's session, or in today's video, wherein we are going to look for numbers that are going to make calculation easy for you. So do have a look at this entire thing. Do have a look at all the questions and understand what exactly are the shortcuts that we can use, what exactly are the different formulas or theorems that we can use, how to assume numbers, how to use options, how to use all the shortcuts that I mentioned, and you will be done with SI and CI by the end of this video. Now, in terms of installments, there is a very simple formula. We are going to see a lot of questions on installments as well. So you have to understand what is the present value. Meaning, if I lend you, let's say 5,000 rupees, and you come after 2 years and pay me 5,000 rupees, then I am going to be at a loss, because the value of 5,000 after 2 years is going to be less than the value of 5,000 rupees today. So you will have to pay me extra. But if you decide to pay me some amount after 1 year and some amount at the end of 2 years, then what does that mean? If you have already paid me some part of the thing that you had borrowed, then you need not pay interest on that particular part. Because let's say, for example, after 1 year, I have given it to you at 10% per annum. Let's say you are expected to pay me 500 rupees as interest next year, but you suddenly come across some wealth and you pay me 3,000 rupees. What does it mean? You have paid me 500 rupees as the interest on the amount that you had taken, but you have also paid me 2,500 rupees of the capital that I had lent you. Now, what does that mean? It means that you owe me 2,500 rupees, because from the initial 5,000 rupees, you have given 2,500 rupees to me. So now you owe me 2,500 rupees. You will have to pay 2,500 rupees that you owe me and 10% on top of that sum that you owe me right now. So at the end of the second year, you will have to pay me the second installment of 2,750 rupees. Now, how do you get to that? Or how do you equate the installments? Because now this is a complicated process. I will tell you, at the end of the first year, you pay me 3,000 rupees. At the end of the second year, you pay me 2,750 rupees. And that basically becomes complicated. Now, you would have heard of this term called EMI, Equated Monthly Installments. What does this mean? Every month you have to pay the same amount. Now, that makes mathematics or budgeting very easy for you. And you know that, okay, there is this thing wherein I have to pay 2,857 rupees every month and I'm sorted. So that is basically the beauty of EMI. How do we arrive at the EMI? This I basically tells me what should be the value of each installment. And this basically is for the number of terms that you have taken the money from me. So this is the amount that you would have taken from me, and the first installment will be I. You would have owed that money for 1 year. So you are going to discount it from today, right? So we are talking about the present value and how do you discount the difference between the future value and the present value. So that is basically the idea. Don't get into the technicalities of it, is what I would suggest. But just think about this thing. If you are going to give me I after a year, or you are going to owe I from me for 1 year, then I upon 1 plus R by 100 becomes the thing that you will be giving me. That is the part of principal that I will be getting at the end of 1 year. So just remember it like this. So present value will be I upon 1 plus R by 100 plus I upon 1 plus R by 100 the whole square, because 2 years you would have owed me. I3, the third installment, upon 1 plus R by 100 the whole cube, and so on and so forth, till the time you are saying that IT, the teeth installment, upon 1 plus R by 100 raised to T. So these are all the formulas that you need to understand in order to be able to solve questions from SI and CI. So make sure that you know this slide, you have saved this slide entirely in front of you. I also put the image in the description box below. So do download it, and then you can kind of answer the questions as well. Let's start with the first question. But before that, I'm going to talk about the CAT Quant workshops that we have launched. So CAT Quant workshops are for all of you who are either finding it difficult to go through quant, or on the other hand, looking for something that will advance your preparation and take it to the next level. I've always believed that excellence in quant is basically a function of how you are taught quant. And if you can resonate with the way I teach quant, then do sign up for these workshops. The workshops are going to start from the 17th of August. And we are going to have 30 live workshops this time, and also 2000 plus questions that are going to be there. There are going to be strategy sessions as well. And also there will be a Telegram group for all the joinees. So sign up for the workshops before the batch gets full, and make sure that you enjoy the workshops to their fullest. Now let's start with the first question. So what I will suggest is you try this question out on your own, pause the video, find out the answer, then look at what the actual answer is, what the actual solution looks like, and then you will be able to kind of understand what exactly you did that was right, or what exactly could have been done in a better manner. So let's look at this. After how many years approximately would the amount payable on a loan be twice the principal if principal is lent at 20% compound interest compounded half yearly? Now, if the principal is if the principal is lent at 20% compound interest compounded half yearly, we know that every year you are going to get 20% back. And as we saw in terms of the rule of 72, you are going to get slightly more than 20% every year. But if you look at it as 20% itself, then what is going to happen? 72 divided by 20 will mean that you are going to take 3.6 years to double your investment. And as we know, 3.6 is very close to 4 years. So that is going to be our answer. Even if we had invested it at 20% interest, we would have taken 3.6 years to double it, which basically means that it is going to be very close to 4 years compared to 6 years or 8 years. And that is why the correct answer to this question is going to be option C. Let's look at the next question. Now try this question on your own and then have a look at the solution. Now we are talking about the difference between compound interest and simple interest. So do have a look at it, and then you can look at the solution. So let's start. If the difference between the compound interest and the simple interest at the end of 2 years is 100 rupees. Now the difference is known to us. What is the principal in terms of rupees? And we know that the rate of interest is 5% per annum. We have to assume that the principal is also the same in both the cases. So rate of interest is 5% per annum. We know that for 2 years, what exactly is going to be the difference between the SI and the CI? It is P into R by 100 the whole square. Now we know that the difference is 100 rupees according to the question. We also know that R is 5. So we can basically say that P into 5 by 100 into 5 by 100 will be equal to 100 itself. So we can just cancel out 25, 4s are 100, and that's why we'll get the principal as 40,000 rupees. So we will know that if we are talking about the same principal, then the principal here is going to be 40,000 rupees, which is also going to be our answer. Very, very straightforward question. Let's look at the next one, and things are going to become slightly complicated as we move on. Seema lent part of the 10,000 rupees that she had to Isha, one of her friends, at 8% simple interest for 4 years. She invested the remaining amount at 12% simple interest. Total income from interest after 4 years. So both these principals have been invested for 4 years. The total income was 3,800. what was the sum that she lent to Isha? Now you have to tell me how will you solve this particular question. So pause, solve, and then see what I do. Now this is a very classic case in which you can use alligation rule, because you are splitting 10,000 into two parts and the mixture is going to give you something else. So you have to understand one thing here. Let's say, for example, if she had lent the entirety to Isha, all the 10,000 rupees that she had, the entirety of that principal she had given to Isha at 8% SI for 4 years, then how much money would she have got? 8% SI over 4 years is going to give me 32%. Now what is 32% of 10,000? We will say that it is 3,200 rupees. So if she had lent the entirety to Isha, then she would have got 3,200 rupees. But if she had given the remaining part of the amount at 12% SI, then what does it mean? If she had invested the entirety of 10,000 rupees at 12%, then in 4 years she would have got 12 into 4, that is 48% return. So the other part would have given her 48% of 10,000 or 4,800 rupees. But what is she getting? After 4 years, she is getting 3,800, which is somewhere in the middle. Now, this is basically a mixtures based question. So, what is going to be the gap here? 4,800 minus 3,800 will be 1,000, and 3,800 minus 3,200 will be 600. So, I am going to get the entire part divided in the ratio of 1,000 is to 600, or you can say 5 is to 3. Now we are talking about what was the sum lent to Isha. So out of the 8 parts that were there, 5 parts were lent to Isha. So my answer will be 5 by 8 into 10,000, or 5 into 1250. Now if you know 5 by 8, your life will become slightly easier, but let's solve this. 125 into 5 is 625. So my answer should be 6,250 rupees that were lent to Isha, and 3,750 were lent to someone else. So the correct answer is 6,250. Let's move on to the next question. Now this is basically something wherein you will be able to apply the difference between SI and CI concept. You know the interest per annum, you know the difference, you know that the parts are invested on SI or CI. You have to find the sum or principal. Now this is very straightforward if you know the formula. So try to apply the formula on your own, find the answer, and then have a look at the solution that will follow. So now the formula here is fairly straightforward. We know that the 3-year difference between SI and CI for the same principal is going to be P into R by 100 the whole cube. As I said, P R cube plus 3 into P into R by 100 the whole square. So I am going to get 3P into R by 100 the whole square. Now that is the gap. But I know that the difference is 512. So I'll just say it is 512. I also know that the value of R is 20. So what will happen here? I will say that this is P into 20 by 100 is 1 by 5. So 1 by 5 into 1 by 5 into 1 by 5 will be 1 by 125. Plus 3P into R by 100. That is again 1 by 5. 1 by 5 into 1 by 5 is going to be 1 by 25. Now if I just simplify the terms, what am I going to get? 512 is equal to P upon 125 plus 3P upon 25. Can I convert this to 125? Absolutely yes. 25 into 5 is 125. But I have to maintain the sanctity of this fraction. So 3P upon 25 will be what upon 125? It will be 15P upon 125. Therefore, what am I going to get? 16P is going to be 512 into 125. I can cancel out 16 from here and here. I am going to get 16 3s are 48. I will be left with a 32. 16 2s are 32. So what will be the value of P? 125 into 32. Now if you know that 125 into 8 is 1000, then 125 into 32 will be easily 4000. And that is basically what we are looking at. The sum that could have been invested on SI or CI is going to be equal to 4000 for this particular question. I hope you are following along. If you have any doubts in any of the questions that I have discussed till now, do let me know in the comments section and I'll try to help you with your query. But do make sure that you are trying these questions out on your own and then you're having a look at the solution, because now the questions are going to become slightly difficult as well. Let's look at the next question. In this question, we are going to look at installments. So again, try this out, refer to the formula that I had mentioned earlier and then check out the solution that's going to follow. Now, Vaishali borrowed some money on compound interest. So she borrowed some money on compound interest and returned it in 3 years in equal annual installments. So my life becomes much easier, equal annual installments. The rate of interest is 15% per annum and the annual installment is 486680. You have to find the sum that she had borrowed. Now what you can do is you can use the on-screen calculator for this one. You can use your phone calculator for this one. Specifically, if you're finding it difficult to calculate, that is completely okay. Now let's see what is happening here. Now Vaishali borrowed some money on compound interest and returned it. We know that the annual installment is 486680. So what was the sum that she borrowed? So let the sum that she borrowed be S. Now according to our installment formula, what is going to happen? It is going to be I upon 1 plus R by 100. So after 1 year, the second installment will be I again, and the current value will be I upon 1 plus R by 100, the whole square. And the third installment is also I, because equal annual installments are expected. And I'm going to get 1 plus R by 100, the whole cube. Now what we'll have to do is we'll have to write down the value of I and we'll have to calculate this. Now 15% per annum, 1 plus 15 by 100. You can safely say that it is going to be 115 by 100. And if you are good at calculation, you can say it is 23 by 20. So you have to look at this one. So I'll get 486680 by 23 into 20 plus, again you will get 486680 upon 23 into 23, and you will get multiplied by 400 because 20 square is going to come to the numerator. And the third part, again you will get the same thing. 486680 into, instead of 400, now you are going to get 20 into 20 into 20, that is 8000. Of course, the numbers are slightly weird, and you are going to get 23 into 23 into 23. Now, if you are very good at calculating, you can just try to cancel out the terms and see what happens. So let's see what happens. 23 2s are 46. I am left with a 26. 23 1s are 23. I am left with a 36. 23 1s are 23. I am left with a 138. 23 6s are 138 and I'm left with a 0. So my first part is 21160 into 20. What about the next part? Now I know that if I cancel these two terms, I'm going to get 21160 from the first case. Now let's cancel out this and see what happens. 23 and 211. You will know that 23 into 9 is 207. So I am left with a 46. So what am I going to get here? If I look at 21160 by 23, right? So I'm going to get 23 into 9 is 207. I will be left with a 46. So I'll get 23 2s are 46 and zeros are 0. So 21160 by 23 is 920. You can think about it, 23,000, a little bit less than that. So now I know that if I cancel this out and 2 23s, I'll be still left with a 920. And now I know that 23 4s are 92. So I'm left with a 40 here. So 40 into 8,000. Now this might be slightly easier to calculate. So let's calculate this as well. 21160 into 20. What am I going to get? 21,000 into 2 is 41,000 or 42,000. And 160 into 2 is 320. So I am going to get 42,320 and one more 0 at the end. 920 into 400 is going to end in 3 zeros here. 92 into 4 is what I'm expecting. 360 plus 8 is going to be 368. So 36800. And what about this? I'm going to get 32 followed by 4 zeros. So 4 zeros and 32. So this is going to be the final thing. So what is going to happen? I'm going to get a 0 here, 2, 8 plus 3 is 11, 6 plus 2 plus 2, 10 plus 1, 11, 4 plus 3 plus 3, 10 plus 1, 11. So my answer is going to be 111200. You could have used an on-screen calculator and could have made your life easier, but this is not very difficult calculation. Now considering that this was a theta question, I expect the numbers to be divisible and to give me good numbers. Of course, the question did not ask us approximate values. That is why we are safe. And the answer is going to be 111200. So I hope you are able to understand the installments part as well. Let's go to the next question. Now again, try this. This is again a very manageable question. So try this out, pause the video and then come up with the answer. Then have a look at what I'm going to say. Now, a person started a business with a capital of 60,000 rupees. In the first year, he made a profit of 20% and added it to the capital. In the second year, he made a profit of 10% and again added it to the capital. In the third year, he incurred a loss of 10% and he set off the loss from the capital. It's okay. Had he invested the money in a bank that pays 10% per annum compound interest instead of in the business, how much more would he have received? That is the point, right? 60,000 if he had invested at 10% per annum CI, then how much more money would he have received? And we are talking about 3 years of interest that he's going to get. So let's look at this. Now, if you look at this and you start calculating every year, you are going to be in some amount of trouble. So we are going to look at successive percentage change here. So 60,000 was what he started with. He made a profit of 10%. So what happened to the amount of money that he had? It increased by 10%. And the new capital that he had is 110% of what he had earlier. 110% is 110 by 100, 110% per 100. Or you can say it became 11 by 10 times of what it was earlier. I missed the first part, but it's okay. He could have made a profit of 20% in the second year. You can just change the order. It will not matter at all because successive percentage change does not, the order does not matter in successive percentage change. So if he made a profit of 20%, then what would have happened? His value or whatever he had earlier, it would have become 120 by 100 times of itself or 12 by 10 times of itself. In the third year, there was a sad situation and he made a loss of 10%. So what happened to the value that he had? The value became 9 by 10 times of itself because it fell by 10%. Now, if you look at these three zeros, we'll be able to cancel these three out and whatever remains, that should be the amount that we are going to get at the end of the day. So let's calculate this and see what happens. I'm going to get 12 9s are 108 and 108 into 11 is going to be 1188, right? So 108 into 11, 11 8s are 88, 11 1s are 11. This is what I'm going to get. 1188 into 60, or I'm going to get 0 here. 8 6s are 48, 8 6s are 48 plus 4 is 52, 1 6s are 6 plus 5 11, 1 6s are 6 plus 1 7. So 71280 is what he would have received in the business. What about the 10% per annum compound interest scenario? What would have happened here? Had he invested at 10% per annum CI, then what would have happened after 3 years? The amount with him would have been 60,000 A equals P into 1 plus R by 100 raised to N. So I am going to get 110 by 100 or 11 by 10 the whole cube. So I am going to get 60,000 into 11 by 10 into another 11 by 10 into another 11 by 10. And I'm going to be able to cancel out the three zeros. I'm going to be able to cancel out the three zeros. And what will I be left with? 11 cube. If you know it by now, it's 1331 into 60. I could have also taken the difference between these and figured it out, but it's okay. You can calculate it. It's not a problem. 6 1s are 6, 6 3s are 18, 6 3s are 18 plus 1 is 19, 6 1s are 6 plus 1 is 7. So 79,860 is what he would have got. He got 71,280. So how much more he could have received? 0 minus 0 is 0. 16 minus 8 is 8. 7 minus 2 is 5. And 9 minus 1 is 8. So 8580 is what he should have got. That is also the answer. So 8580 would have been the extra money that he would have got had he not got into the business and had got 10% per annum as compound interest, right? So that is basically what would have happened. Now you can see what happens here. He made a profit of 20%. Then he made a profit of 10%. But then he incurred a loss of 10%. So 20, 10 and 10. We are basically looking at an absolute growth of 20% in general. I'm not talking about plain terms, but he would have grown by 20%. But in terms of compound interest, he grew by 30% virtually, right? So that is basically the point here. So even if you keep on growing by 10, 10, 10, that is more valuable than growing by 20, growing by 10, but then losing 10. That is very important. Let's look at the next question here. Now, this might sound a bit tricky, but try this out and then have a look at the solution that's going to follow. So here Aditya borrowed a sum from Balu at 6% per annum simple interest and thrice of that sum from Kamla at 10% per annum simple interest. He added some more money of his own and lent the whole sum to Shahid at 15% per annum simple interest. So he's basically doing something that you can call subletting. He's taking money from one place, he's giving it on interest to someone else, and whatever is the difference between the two, he is basically earning. You have to tell me in the comment section which business follows this same model, and the top winners will get a shout out, right? So do tell me what you think is the answer to this particular question that I answered, and we will talk about you in the next session some way or the other, right? So you have to understand, at the end of the year, Aditya gained 6,600 rupees because of this entire arbitrage opportunity. If Aditya lent 80,000 rupees to Shahid, then how much money did he borrow from Kamla? Right? So he lent 80,000 to Shahid, which was the 15% per annum transaction. And this was basically consisting of the amount that he took from Balu, some amount that he took from Kamla, something that he added from his own pocket, and that was 80,000 rupees. So that is basically the point here. So let's see what we can do with this particular thing. So let's say, for example, he borrowed X rupees from Balu. So I'll just write this. Let's say he borrowed X rupees from Balu. What about Kamla? He would have borrowed 3x rupees from Kamla. He added some money of his own. So let's say Aditya added Y rupees of his own. And he lent the entire thing to Shahid at 15% per annum simple interest. And we know that Aditya gained 6,600 rupees. Now, one way of thinking about this is, let's say, for example, Aditya gained 6,600 rupees, but Aditya had lent 80,000 rupees to Shahid. So what would be the amount that he would have got from Shahid? He would have got 80,000 rupees and the simple interest that would have been accumulated on this 80,000 rupees, right? Now you have to understand one thing, what exactly would have happened here in terms of X, 3X and Y. Now he borrowed something from Balu at 6% per annum, right? So if he borrowed 6% per annum or he borrowed at a rate of 6% per annum, then he would have to pay back 6% at the end of the year. He borrowed something from Kamla at 10% per annum. He would have to pay back Kamla at 10% per annum. Now, in one thing that you can do is, instead of X, 3X and Y, what you can do is you can take better variables. You can take it as 100X. You can take this as 300X and you can take this as 100Y instead of these, because the percentage bit is going to be taken care of. Now, understand something. How much would have Aditya earned, right? Aditya lent 80,000 rupees to Shahid. So Aditya would have got how much money out of Shahid? Shahid would have paid him 15% simple interest. So 15% simple interest and 80,000 rupees. What is the money that Aditya would have got at the end of the year from Shahid? He would have got 15% of 80,000, or he would have got 8,000 plus 4,000, that is 12,000. So 12,000 is what Aditya received. How much is Aditya supposed to pay to Balu and Kamla? He has borrowed 100x from Balu. He is supposed to pay 6%. So out of this, 6x will go away to Balu. He has taken 300x from Kamla and he has to pay 10% back to her. So he has to also pay 30x to Kamla at the end of 1 year. But what is the gap? He got this many or this much extra money from Shahid and he has to pay back this much extra money to Balu and Kamla. What will be he left after this entire thing? He gained 6,600 rupees. So he'll be left with 6,600 rupees at the end of this. So what is going to be the case here? We have to find out how much did he borrow from Kamla. So we have to find out what is 300x. So let's see. We are going to get 36x equals 12,000 minus 6,600, which is 5,400. So if you look at this, 18 2s are 36. 18 3s are 54. So I'm going to get 300 here. You can also cancel this out and you will get 150. So if x is 150, what is going to be 300x? It is going to be 300 into 150. That is 45 followed by 3 zeros. So what was the amount that he had borrowed from Kamla? The answer is going to be 45,000 in this particular case. I forgot to change this. So this should be 45,000 for this particular question. I'll get it altered. So 45000 will be the answer for this one, as you can see on screen right now, right? So the answer to this question is 45,000. Let's look at the next question now and let's see what we can do with this one. So try this again and then you can have a look at the solution that's going to follow and try this out. It's a very interesting question. You might be tempted to use something, but then you will realize you can't use that and then you will fall back to the method that you know the best. But let's see if there's a better method. So write this out and then we'll discuss this. Right? So let's look at this. The difference between the simple interest for 3 years at 8 and 1/3% per annum on a certain sum and the compound interest for 3 years at 12.5% per annum on the same sum compounded annually is 5340 rupees. Now the funny thing here is we are used to figuring out the difference between SI and CI for a particular sum at the same rate of interest. But here the rate of interest is changing. We have 8 and 1/3% per annum and we have 12.5% per annum. Now, how do we figure this out? So you have to understand one small thing here, right? At the end of 3 years, what is going to be the simple interest that is going to be accumulated on the principal that we have? So let's say the principal is P. In terms of simple interest, what is the interest that is going to be generated? The interest that is going to be generated is I equals P into R into T by 100. So P into rate of interest. 8 1 by 3. What is 8 1 by 3? It is going to be 25 by 3 into the amount of time, that is 3 years, and of course you will have divided by 100. So we are going to get interest equals P by 4, or in other words, the amount if you invested it at simple interest would be principal plus principal by 4 or 5P by 4. That would have been the amount that you would have received at the end of 3 years if you had invested it on simple interest. You could have also said that you are going to get a 25% alpha on this particular investment. In terms of compound interest, what is going to happen? In terms of compound interest, the final amount that you are going to get is going to be equal to P into 1 plus R by 100. Now what is R? 12.5%. What is 12.5? 12.5 is nothing but 1 by 8. Right? If you look at it. So 12.5% is 12.5 by 100, or it is going to be 1 by 8. So P into 1 plus 1 by 8, the whole cube, because he is going to invest it for 3 years itself. Now what is going to happen in this case? You are going to get some amount that is going to be 9 cube by 8 cube, or you are going to get 729P by 512. Now the funny thing you can do here is, you can, instead of getting into the calculations here, you can say let the principal be equal to 512x to eliminate this entirely. So if you are looking at the amount through SI, I am going to get 5P by 4 or 5 into 512x by 4. And amount, had I invested it on compound interest, is going to be 729 by 512 into 512x or 729x. Right? So this is what we are going to get. What about this one? I'll just cancel this. I'm going to get 4 ones are 4. I'll be left with an 11. 4 twos are 8. 32. 4 eights are 32. 128 into 5 is going to be what? 640. So 729x minus 640x is going to be the difference, and that is going to be equal to 89x. Now I know that 89x equals 5340. So what will we get here? 89 into 6 if you do, because 9 6s are 54. Generally, 89 into 6 will be 19 into 6, 540 minus 6, that is 534. So I am going to get x equals 60. So what is going to be the principal? It is going to be 512 into 60, which is going to be 0 as it is. 6 2s are 12, 6 1s are 6, plus 1 7, 6 5s are 30. So I am going to get my answer as 30720, which is also the answer to this particular question. So you can just check out the calculation once, you can just try this once and you would be sorted. Let's look at the next question. Look at this one, try this out on your own and then have a look at the solution that's going to follow. So Paresh borrows 10,000 rupees from a bank at 1% interest per month. Each month he pays back 400 rupees towards the principal plus the monthly interest on the outstanding balance. This is very important. A lot of people will make a mistake here, but he's paying monthly interest on the outstanding balance. By the time the loan is repaid, how much money would he have paid the bank? That is the question. So it is not a difficult question if you understand what exactly needs to be done. So you have to understand one thing. Each month he is paying 400 rupees. So let's say what happens at the end of month 1. At the end of month 1, what is the money that he is paying to the bank? He is paying 400 rupees. Yes. But he also owes 1% interest on the 10,000 that he owed at the beginning of the month. What is 1% of 10,000? It is 100 rupees. Now what happens? Now if you look at what is happening next, at the end of month 2, what will he be paying? A lot of people will think that it is 400 plus 100, but no. After he has paid off 400 rupees, he now owes 9,600 rupees to the bank. So he is again going to pay 400 rupees as a part of the principal, and 9,600 he is going to pay 1% on top of 9,600. So he is going to pay 96 rupees interest. Then what will happen at the end of month 3? Now out of 9,600 he has already paid 400. So now he is left with 9,200. So what will happen? He will end up paying 400 as the principal, plus he will pay 92 rupees. And this will keep on continuing till the time he pays 400 rupees and 0 rupees as the final interest. Right? That is what you have to understand. But if he's paying 0 rupees as the final interest, it basically means that he would have paid off the entire thing before this month itself. So what would be the final payment that he will do? He will do 400 plus whatever he owed on that 400. That is going to be how much? It is going to be 4 rupees. Because at the beginning of this month, he would have owed 400. So he paid off those 400 rupees that he owed, and he also paid 4 rupees interest on this. So the total is going to be what? In this case, the total is going to be the addition of all of these. So you have 4, 8, 12, 16 till 100. So we have 25 terms here. So we have 25 installments. So he would have paid 400 into 25, that is 10,000 that he owed the bank, plus he would have paid 4 plus 8 plus 12 and so on and so forth till the time he reached 100. Now what will be the solution to this one? It will be 10,000 plus there are 25 terms. So 25 by 2 into first term plus last term. Right? So n by 2 into 2a plus n minus 1 into d, or you can say the first term plus last term, because this is an arithmetic progression. So I am going to get 52 into 25. Now 52 into 25 is 13 sets of 100. So I am going to get 10,000 plus 13 sets of 100. So my total, or Paresh's total amount that is going to pay back to the bank is going to be 11,300 rupees. It's very important. A lot of people will think that it is 25 into 500 and 12,500, but that is not the case. It is going to be 11,300 because as the months progress, Paresh will owe lesser and lesser amount to the bank. Now let's look at the last question that we have. I believe that's the last question. Yes. So check out this particular question. Try this out on your own and then have a look at the solution that's going to follow. If you have gone through the entire video till now, this is going to be a piece of cake for all of you. So try this out. Now Dharmendra borrowed 5,460 rupees from a money lender and repaid it in 3 equal annual installments, and the compound interest is 20% per annum. Now I don't even need to talk about the formula here. I know that the amount that he had borrowed was 5,460. This would be equal to the first installment 1 plus r by 100. So 1 plus 20 by 100 is what you're going to get. In the second year, what would have happened? Again, he paid the same installment, 1 plus 20 by 100 the whole square. And in the third year, what would have happened? He again would have paid an installment at I, but its current value is divided by 1 plus 20 by 100 the whole cubed. Now you just have to find the value of I. It's very, very straightforward. So let's try this. 5,460 will be equal to what? You can just do it as 1.2, or you can just put it as a fraction and do it. Either way is fine. So I'm going to get 120 by 100 or 6 by 5. So I'll just write this as 5i by 6. Now I know that this is 6 by 5 square. So I'm going to get 25i by 36 here. And again, I'm going to get 6 by 5 the whole cube. So I'm going to get 125i by 216. Now what we can do is we can just equate all the denominators to 216 so that it makes our life easier, and we will look at what happens to the numerators. So if this has to become 216, it has to be multiplied by 36. The numerator also gets multiplied by 36. I am going to get 180i here. 25 into 6, 36 into 6. So I am going to get 150i here. And 125 will remain as it is because the denominator is already 216. So I am going to get 180 plus 150, that is 330. Plus 125, 430, 455 is what I'm going to get. So I'll basically say that this is going to be 5460 into 216 upon 435, right? So you can use basic calculation and you can figure it out. Let's cross out the 5 from here. I'll get 5 8s are 40, 5 7s are 35. I will get 5 1s are 40, 0, 5 9s are 45, and 10, 5 2s are 10. Now 87 will help me cancel out a 3 as well. So let's cancel out a 3 from here. I'll get this as 29. And I'll be able to cancel out a 3 from here. So I'll get 3 3s are 9, 3 6s are 18, 3 4s are 12. Right? Now 29, what can we cancel this with? Right? So 29 into 5 is 145. 29 into 6, 29 into 7, 29 into 8. You will have to keep on doing this, and you will try to figure out what exactly happens here. If you don't want to get into all this trouble, what you can do is you can use the on-screen calculator and you can try to figure out the answer to this one. So it's 364 into 216 divided by 29. So our answer is going to be slightly weird here. So I might have made a mistake somewhere, but let's try to see what that mistake was. Let's see. So I'm going to get 1 plus 20 by 100, 1 plus 20 by 100, 1 plus 20 by 100. 5460 was what was lent. Fine. 5460 is 6 by 5 here. So 5 by 6. Fair enough. Again, this is 1.2, or we'll get 125 by 6 the whole square, 25 by 36. Yes. And this is 5 cube by 6 cube. This makes sense. Then what will happen? If I am converting this or multiplying this by 36, 36 into 5 should be 180. That makes sense. 36 into 6 is 216. 25 into 6 is 150. Fair enough. And 125. Let's add these three again and let's see what happens. So 180 plus 150 is 330. 430, 440, 455 I, and 216 is what we have. So I might have made a mistake in terms of the division. So let me check this once and we will see what exactly can we do to fix the mistake that I might have made. Yeah, so the thing that I made here was I just added it incorrectly. So this is not 435, it is 455. So once we do that, we should be able to find the answer very easily. It's not a difficult question at all. I made a small mess of it, but we can correct it. Nothing that can't be changed. So if you calculate it properly, use a calculator, then you should be fine. But this has to be divided by 455. So I'm going to get 91 here. 5 ones are 5 zeros, 5 nines are, and I'm going to get 5 twos are 10. Right? If I use 13 into 7, then I should be able to get something here. So I will be able to see one thing here, which is 91 into 12 is 1092, but let's try to do 13 into 7. So let's say I divide it by 7. So I'm going to get 7 ones are 7, 39, 7 fives are 35, 42, 7 sixes are 42. 13 into 12 is 156. So my answer is going to be 12 into 216. That is 2400 plus 192, which is going to be 2592. So you can use the on-screen calculator or you can use the calculator to make sure that you don't get a lot of grief. Let me know how many of you spotted this error before I did in the comments section. I will know that you have been here with us till the very end if you managed to do that. But I hope this was useful to you. Do not forget to subscribe to the channel if you like this content. Do not forget to like the video, share it with all of your friends who are struggling with SICI, and I'm sure you'll get a lot of blessings in return. I'll see you again in the next video. Till then, take care everyone, and let me know what did you think about this particular thing. We are waiting for your replies. So see you in the next video. Till then, bye everyone.